Hi guys, welcome to our channel Swipe to Learn. Welcome to our video on OOP concepts with Python. Most instructors skip OOP in beginner Python courses, but we are here to change that. Many believe OOP is exclusive to Java, but we are about to show you how simple it is easy to apply OOP principles in Python. Learning a basic Python may not be yet efficient and suitable to write complex programs and coding paradigms, but learning Python with OOPS will help you to a great extent in programming. In this video and the coming videos, we'll be diving into the world of object classes, inheritance, and many more. You will learn how to write more efficient, readable, and maintainable code using Python OOP features. In this first video of OOPS concepts, we'll be learning about class, object, variables, and instance. Don't worry about the concepts and the terminology. We will see about each and every word in detail. So, what is OOPS? OOPS is object oriented programming. Whatever we see is completely OOPS concepts in day to day life. So, OOPS helps in structuring the code, like it helps us to make the code modular, readable, and scalable, reusable. It enhances code maintainability, security, and efficiency. Okay, key concepts of OOPS. Like if you want to know about OOPS, you must learn about the class, object, encapsulation, inheritance, polymorphism, and abstraction. If you know about these six concepts in OOPS, you are done with the OOPS and you can start building your own applications, right? So let me say the four pillars of OOPS. So encapsulation, abstraction, polymorphism, inheritance. I'll be discussing about each of them in the coming videos in detail, but let me give you a glimpse on these four pillars of OOPS. And then in the next slides, we'll be seeing what is class and object. So what is encapsulation? As you listen and use as a sense with the name, it's like something capsule, like protecting something in a capsule over. You get into the medicine in the capsule. You don't know about the medicine, but it is completely protected. Same here, encapsulation protects sensitive data and prevents accidental modifications. Like if you go with a college database management system, like you get into the data. Okay, let me say a website of your college where you'll be seeing your results, right? So, and you'll be getting the complete user management, student management, everything in your college management system. If you have the privileges of seeing and modifying the data, I think no college gives you that permission, right? So, if you go and see and you modify your attendance, so then everyone will not have any attendance problem, right? Everyone will be with the 90 percentage, right? So this is encapsulation. Like whatever the privileges you have, like a entity or a user process. So those are only the privileges given in the encapsulation. Like it protects the sensitive data and whatever the modifications to be happened. Abstraction. Hide unnecessary details and making the interface cleaner. So you just have a page where you enter your roll number, your maybe your semester and everything. When you click on submit, you will be opening into a new dialog box of all your results, right? So do you really need or do you really wanted to know how your the backend is going to work, like how the result is going to a database, how your roll number and your semester are mapped, and then your result sheet is getting generated here? It's nothing. It's just a matter of second. When you just click on the submit button, all the details whatever you want you'll be coming up to the paper, right? So abstraction is something a basic concept, like where it hides unnecessary details and make the cleaner interfaces. And then polymorphism. It supports flexibility and allowing different behaviors for the same function. Like you need to suppose you have multiple departments. A department performs some function, like every department have the student database, every department have their courses, every department have their own results, exam scheduling, everything. These four functions will be same, right, for each and everything. So where polymorphism, like it's different behaviors. Suppose if a student comes, what are the student actions? The person may be same for the results. So if the student comes, what he or she can do, he'll just view the result. Whether if a student or sorry, a faculty comes, so the function is same, viewing results, but based on the input parameter, it may be a student, faculty, or an admin. If admin gets, he gets access everything, right? If a faculty gets, he views the results of the complete class, right? So viewing results is the same function. Based on the input parameter, the output varies. This is called as the polymorphism. So it supports flexibility, different behaviors for the same function. Inheritance. So if the department of CSE contains the same functions and the department of ECE contains the same function, department of EEE contains the same function. Like say these are the functions 1, 2, and 3. Instead of writing it again and again, you can just inherit the class, like getting your parent properties, getting the. So instead of this, I'll define a new class department which consists of all the functions. So each and every my CSC department, this takes from all the properties from the department, like inheriting all my parent properties, that is the inheritance. And the ECE takes from all. Instead of writing 3 times code, I'll just write 1 time in the department class, and all my other classes, whether I add a new department also, they will be inheriting all the properties from their parent class. This is the inheritance. I hope you got clarity on how these features works, right? Yep. So let's see with the basic and the most used name, the noobs concept, that is class. What is class? A class is something which consists of objects. So for that, you need to know about objects, right? Object. An object is an instance of a class. Sounds confusing? Class is something where you get a collection of objects, and an object is something where you get an instance of a class. See. So let's see. Classes are blueprints for creating objects. Like class is something watch which we have something unique defined by us, and it consists of set of attributes and methods. Attributes something called as parameters, methods are called as the functions. Suppose if you say a class car, a car consists of its brand name, its model name. So if a brand X, model X is a car, and model Y, brand Y is a different car, right? So these are all different objects. So if you have an object X, object Y together for a class car, so I can define class as a collection of objects that may be X, Y, Z, so on. So important points are class. The creation of class is class keyword followed by class name and followed by colon. Attributes are the variables that belongs to class, and attributes are always public. You can access the attributes by using calling them. Suppose car dot brand gives me the result of what is the brand here. So if I go with car dot model, it gives me the answer of model here. So these are public and you can be accessed with the dot operator. Let's move on to next. Object. Object is an instance of a class. Like it is the class is the blueprint, and in the blueprint we have many several, it's a collection of objects. If we take one, that is an object, it gives a unique and specific implementation of the particular class. If you want to implement a class, you need to create an object, right? So it's something like kind of container. If you pour something, then only it will be useful, right? So an object consists of state, behavior, and identity. State are called as attributes. Behavior is called as methods. Suppose a car, it starts, it moves. So these are all the actions. Identity is a unique name. So how to create an object? Just like a function by initiating with parameters. So this is my class car and I am giving the parameters. Like what are my parameters in the previous slide? You see brand and model. These are the parameters, and I am creating a new object car1. If you want to create for another one like Y, I can also create car2, car of something X, Y, right? And I told you can access them by using dot operator. If you go with car1 dot brand, it gives us Tesla. If you write print car1 dot model, then it gives model S, right? This is class and object. Okay, shall we implement this? Why not? Let me initialize a car. Okay, let me copy this. Let me initialize car1, car of. See, you got your parameters like self of brand, comma model. So let me give model as Tesla. Okay, it's brand. Model is some XX. Okay. As I told, you can access print of car1 dot brand gives me the brand, and let me print car1 dot model. So you got your Tesla X. What if I give as car2 dot model? Car2 is not defined. So this is how you can add. If you want to add another parameter, you can just give self dot what I give. Okay, color equals to color. Let me add it in the parameters also. Check with this. I think, okay, you see, because we have an initial required position argument color, it's same thing kind of function. If you give color equals to none here itself, this works. See, you got your Tesla. Same as default and position arguments. If you just give here, then you must give here the color. So let me give blue. Let me write over in the string. So now it works fine, right? I think you got overview. It's something simple like just the functions, how you use them. So if you go with your Java concepts, you have to write in a long way of writing the class, initializing them and everything. Okay, let's get back to our, so you're done with your class and then you're done with your object. Now, did you wonder what is self here? So self is a parameter. It just refers to a current instance of the class. So it allows us to access the attributes and methods. So self, it just tells this is to my class self. Like this self represents this car. And so if you want to access the parameters or attributes, these are called as attributes, right? You also have functions. So attribute self dot brand. So what self indicates in this class, in this instance of the class, what is my value for my parameter brand? So this is self. And you also have init here. Let me erase the screen. Yep, init. So init, it's a constructor in Python where whenever you create a new object, it just creates. So whenever you call the function car off, it just first go and initiator, okay, initialize the function def init, and then it checks with the parameter self brand model, and then this function, I mean the object is created. If you want to add the methods after this def init, you can write below def run. It prints, if you call the car1 dot run, it just says car is running, like this. I hope you get the difference between self and init. Self, it's a parameter, it just denotes it is in the current instance of the class, and init method is to tell, like instantiate the object. So let's see with the variables, class variables and instance variables. Okay, if you see, okay, let me say with the definition. Class variables. These are the variables of the class itself across all instances. Like means they are constant in all instances of the class. So they say they share the same value, whereas instance variables they differentiate. Like these are defined within the init method and these are unique to each instance object of the class. So let's category transport. So this class variable, that is the category. So according which category this class belongs is the transport, right? So if you see with the self dot brand, self dot model, like brand model, these parameters are defined for an object. So these are called as instance variables, whereas this class has are called as class variables. So if you create a new car object, like car2 is equals to something like, if you just call car2 dot category, it also generates the same value transport. So car1 dot category also generates the same transport value. So this is like a fixed constant one, whereas the self dot brand model, these are the instance parameters. Like if you go with here car1 dot brand, whereas car2 dot brand gives you different results, right? So if you see with the instances like class dog, this is the dog. What are its attributes? Its breed, age, color are its attributes or state, whatever we call, and behaviors or methods. Those are bark, sleep, and eat. These are the methods or behaviors we can call. So we can create number of instances. So dog one, dog two, same as like car one, car two, dog three, dog four. These are all the instances of the class dog. A class can have number of instances, right? So we can create n number of instances. So each object is called an instance of a class, whereas class is the collection of the objects, right? So let's see with the use cases where the oops concepts are really actually used. Encapsulation, I told earlier what is encapsulation. It protects the user credentials. So it's mostly used in the banking system where only authorized methods and or the authorized privileges users are granted and those are used in the banking systems. Abstraction example is of car manufacturing where the complex engine mechanisms or the user interactions, those are all in a concise and protected way. We just go with an APIs for the implementation details. Inheritance, common attributes like health or attack power, like these are in base class. So, okay, let me tell in detail. So, if you go with the classes like, so if you say with the character one consist of health of this value, attack of this value, power of 1000, whether a C2 have something. So instead of creating new object for each and every character, it just have a base class character. And for each of the special character, we define the value of health, attack power, its weapons, or if some characters after going on some game, you will be getting a different functionality of becoming a warrior or a mage. Like this, those functionalities will be added without writing or rewriting the code. We just extend by inheriting. After suppose if a character whose attack power or whose killing powers or something is increased or greater than 1000, just inherit the class with the warrior class. Like this you can go with the code. Whereas in the polymorphism payment system, like Process payment works differently for the, it may be a credit card, it may be a Bitcoin, it may be any of the transaction. It enables the flexibility and scalability. And the function works same, the same function works differently on the parameters. If we go with the OOPS in the web development, by using Django, Python, Django and Flask, by using this framework, you can just create a manage models and using uh, different applications. It may be a authentication system or a class management system or a college management, any of this. You can use OOPS concepts in the web development. So that's it for today's video. You have covered your fundamental basic concepts of OOPS, that may be a class, an object, an inheritance, four pillars of your OOPS, how class variables, what are the types of class variables, what is self parameter, what is init method, and so on. We will cover about the next basic and in detailed about the four pillars of OOPS in the coming videos. Stay tuned to Swipe to Learn.